With C would make this a perfect square trinomial, then write the quadratic in factored form. So I'm going to take half of B and square it, which is 13 squared, which is 169. So that's my C. And my factor is X plus 13 squared. Number 3. Solve by completing the square. First thing I have to do is move the 2 over, subtract 2 from both sides. I get x squared minus 10x. I'm going to have to make that a perfect square trinomial, so I'm going to have to find the perfect square. 0 minus 2 is negative 2. I'm going to have to add that perfect square to that side. Okay, half of 10 squared. Well, actually, it's negative 10, right? I like putting a negative sign with it because when I go to put it in perfect factor form, it helps me out. So I have negative 5 squared, which is 25. Add 25 to both sides. So I get my factored form, x minus 5. See how that helps me put it in factored form? And negative 2 plus 25 is 23. Now it said solve, so I have to solve for x. What do I need to do? That's right, kids, square root both sides. Cancel out the power 2. And I get x minus 5 equals plus or minus the square root of 23. Still have to get x by itself. Add 5 to both sides. And I get x equals 5 plus or minus, nothing I can do with the square root of 23. Prime number. Questions? You know what? I've been doing this. I did this like 2 periods, and I didn't have enough time to get through all the problems. So, yes. So, yeah, I am kind of rushing, and this is review, not first time learning, right? Want a pen? I don't have any pens. You want some pencils? Looks like I might be out of pencils, too. Yeah. Here, you want a pen? Okay, number 5. It says put it in vertex form by completing the square. What's vertex form? That's right, y equals a times x minus h squared plus k. Okay, we're going to have to complete the square, so we're going to have to add a perfect square. First thing, let's get rid of this 3 to make it a perfect square trinomial. So I get y minus 3. We're going to have to add a perfect square equals x squared plus 12x plus that perfect square. Okay, my perfect square, half of 12, square it. I get 6 squared, which is 36. Okay, left-hand side. Y minus 3 plus 36 is y plus 33. Right-hand side, my factored form, x plus 6 squared. And then I have to subtract 33 from both sides, right? To get y by itself. So my final answer, $4 million. Y equals x plus 6 squared minus 33. Pardon me? Hi, Gunner. Okay, the next 4 problems, 7 through 10, you're supposed to use quadratic formula. We all know how to do this, right? We did so many problems on our homework. Let's see, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Number 7, what's my a? That's right, kids, 1. What's my b? Very good, what's my c? So x equals negative b, which is negative 9, plus or minus the square root of b, which is negative 9 squared, minus 4 times a is 1 times c is 20. All over 2 times a, which is what? Is that a ball? Rufus, is that a ball? Did I hear a ball? Ball! Sounded like a ball bouncing. All right, so I'd like to do the radical. Get out of her seat. Okay, here's a radical. I have the square root of negative 9 squared is 81 minus 4 times 20 is 80. This is the square root of 1, which is just 1. I replace the whole radical with the number 1. So I have x equals negative 9 is positive 9, plus or minus 1 divided by 2 times 1 is 2. Okay, I'm still not simplified all the way. 9 plus 1 is 10 over 2. 9 minus 1 is, 10 over 2 is 5. Then I have to do the other one. 9 minus 1. 9 minus 1 is 8 divided by 2, which is 4. So my answer here, x equals 4, comma 5. Questions? Comments? Concerns? Okay, number 9. Go watch the video when I'm done. My A is 1. My B is what? That's right, kids, negative 4. What's my C? Okay, so x equals negative, what's B? Negative 4. Plus or minus the square root of b squared. B is negative 4 squared minus 4 times my a, which is 1, times my c, which is negative 8, all over 2 times a, which is 1. All right, do the radical first. So I have the square root, negative 4 squared is 16, minus 4 times 1 is 4 times negative 8 is negative 32. So I get the square root of 48. What's my largest perfect square that's a factor of 48? That's right, kids, 16. So I have the square root of 16 times the square root of 3. Square root of 16 is 4 square root of 3. And I'm going to replace my radical with 4 square root of 13. Isn't that fun? Okay, let's keep going. So x equals negative 4 is positive 4. I'm replacing this whole radical discriminant thing with 4 square root of 3, and it's all divided by 2. Am I done, kids? No, why not? Because you can take out a factor of 2 of every term. So 4 divided by 2 is 2, 4 divided by 2 is 2, 2 divided by 2 is 1. So this equals 2 plus or minus 2 square root of 3 all over 1, which we don't really have to put. So my answer is 2 plus or minus 2 square root of 3. That's as far as I can go, unless you guys can go farther. All right. And that, my friends, is quadratic formula. Sure, you can go use the restroom. All right, 4.8, complex. Any questions on quadratic formula? Yeah, it's pretty, well, yeah, you guys did 100 of these problems. All right, 4.8, imaginary numbers. This is where, you know, some of that mind-blowing stuff might come into play here. All right, -1, square root of -20. Okay, what's before imaginary numbers, you couldn't do this, but now you can. Okay, I can break this -20 up to -1 times 4 times 5. And the reason why I picked 4 and 5 is because 4 is perfect square. Okay, so this becomes the square root of -1, the square root of 4 times the square root of 5. What's my rational number first? Four. So square root of 4 is 2. What's my next order here? That's right, the I. Okay, you guys should know that. Me, I, me. And then square root of 5, the irrational. Stop throwing things in my room. Okay, number 13. Yes. Here, I got a pencil. No, I don't. No. What's coming to me? Something's coming to me. I don't know about that. There's one. There's one. Another one. Hey, number 13. We have a plus sign. So we could just combine like terms. My rational numbers, 9 and 4, 13. My irrationals are all of you guys sitting out there. Positive 3i and negative 9i. Negative 6i. Number 15, subtraction. What do I have to do with the minus sign? That's right, distribute it, kids. So I get 9. 9 minus plus 3i minus 4 plus 9i. Boy, I'm getting all this free stuff. Oh, that's a good one. I'm keeping. Oh, there's another good one. Cool. All right, so I have a 9 minus 4 gives me 5. 7. 3i, 9i, 12i. No. Plus. All right, 17, multiply. What do I get to do? Get into some funner stuff here. FOIL. First, 9 times 4 is 36. Outer, 9 times negative 9. Hey. Give me all that. Anything that you guys throw up here, I'm keeping. Hey, first. 9 times 4 is 36. Outer 9 times negative 9i is negative 81i. Inner 3i plus or times 4 is positive 12i. Hey, stop. Enough. 3i times negative 9i is negative 27i squared. Okay, the I squared is going to make this a positive 27. Combine these, I get negative 69i and 36. Let's see, add the rationals. 36 and 27 is 63. And then I have the minus irrational 69i. 19. Division. How do I do division? Can't leave I in the denominator. So I have to multiply by the conjugate. 4 minus I. And I have to multiply the numerator by 4 minus I. What happens when you multiply by the conjugate? The middle and last terms cancel out, so all I end up with is the first and last. So 4 times 4 is 16. I times negative I is negative I squared. That's just negative 1. So I have 16 minus negative 1, which is 16 plus 1, which equals 17. Then I figure out the numerator. Numerator, I have 13 times 4 minus I. 13 times 4 is 52. And then 13 times I minus 13i. Can't simplify that anymore. That's what I get. All right, 21. 21, I have, I'm supposed to solve this algebraically. How do I get rid of a radical? Wonderful, square both sides. So I get 3x minus 2 equals x plus 15. Solve for x. Subtract x. Subtract x. 2x minus 2 equals 15. Add 2 to both sides. Oh, sorry. And then, no, I don't do I don't do heroin. 2x equals 17. Divide by 2. And I get x equals 17 halves. Number 23. Square both sides. See, I get 7 plus 3x equals 5 squared is 25. Subtract 7, subtract 7. I get 3x equals 18. Divide by 3, divide by 3. I get x equals 6. Number 25. We're supposed to solve this algebraically and graphically. Okay, gonna square both sides. I get x minus 1 equals x minus 3 times x minus 3. I can FOIL that. Okay, I get x minus 1 equals x times x, x squared. Outer x times negative 3 is negative 3x. Enter. Negative 3 times x is negative 3x. I get negative 3x for both, which is negative 6x. And negative 3 times negative 3 is positive 9. I just created a quadratic, so I have to check my answers. All right, I have to get 0 on one side. So I'm going to subtract x and add 1. Subtract x and add 1. This goes to 0. I have x squared minus 6x minus 1x is 7x. 9 plus 1 is 10. And then I showed you the past month and a half, I showed you 4 methods of factoring, right? Solving quadratic equations. 1 was factoring, 2 was square root on both sides, 3 was completing squared, and then quadratic formula. Well, I'm just going to factor this because I can. Of x, that's a plus, that's a minus, so it's minus, minus. Factors to 10, 5, and 2. So, my answers here. X equals 5 and 2. Now, because I created that quadratic, I have to check them. Okay, I have to check 5. Does the square root of 5 minus 1 equal 5 minus 3? Square root of 4, does that equal 2? Yes, it does. 5 checks. 2. Does the square root of 2 minus 1 equal 2 minus 3? Square root of 1 equal negative 1. Nope, doesn't work. 2 is an extraneous solution. So my answer is x equal 5. Then you guys have to do it graphically. So what are you going to do it graphically? Going to put it in your calculators, right? All right, in y1. y1, we're going to put the square root of x minus 1. And then in y2, we're going to put x minus 3. Graph them. Okay, let's draw them on our graph. Go to our table. Let's see my exponent one here. I'm sorry, my radical one here starts at 1, 0. 1, 0. Then I have 2, 1. And I need another whole point. 5, 2. There's my radical graph. Then my line is my x values and my y2. So I have 1 comma negative 2, 1 comma negative 2, 3 comma 0, 3 comma 0. What else do I got? 5 comma 2, 5 comma 2. And to find the point of intersection, I mean, this one's pretty easy because they both have x, 5, and 2. See right there, 5 and 2. So I know that the solution is x equal 5. But if it wasn't that clear, you can go to your graph, go to second trace, go to intersection. It asks for the first curve. Make sure you're somewhere on that line. Hit enter. And then it's asking for the second curve. Make sure you're on the second line. Hit enter. Then enter again. And it gives you the point 5, 2. And of course, we're looking for x, which is 5. Okay, any questions for your quiz on Monday? Actually, surprised I got through this pretty quickly. Questions, comments, concerns? Yeah, x minus 3, yep. Yep, x minus 3. Graph it, and then second trace intersect. Make sure you're, here, I'll do it. Second trace, you want the intersection, hit enter. Make sure you're on a curve here. So we're on the radical graph, radical function graph. Hit enter. Now it's flashing the line graph, so hit enter, and then enter again. And it gets me the point of intersection at 5, 2. Any other questions?